Hello everyone and welcome to this game called Sandbox. Game where you just create a solar system and destroy it. For example, I can just destroy the sun like this. I'll make it grow so big that it goes into supernova, destroys all the planets. Or at least I think. We'll see what happened to Earth. Earth's cold. Look at that. We said global warming was a reality. And this is happening. Anyway, I'm going to open up another save. If I can. If I can find it. Which I can't. For some reason I can't find it. Oh wait, never mind. It's right here. Okay, so there's all these simulations. Right now I'm just going to go back to the regular solar system and see what we can do to wreak havoc in the solar system. First of all, let's see what happens if Jupiter became a star. Let's slow down right down. We'll give it, let's see here. We'll start a nuclear fusion to ignite. It has to be at least 120% the size, or 110%, so just put in that. And now it's a small star. Now let's see what happens to Earth. Right now Earth is experiencing drastic changes because of the double star. Let's see what happens when Earth is in line with Jupiter. Okay, no significant changes. Okay, the planet has reached maybe about an hour-long night time right now, and then pure daytime. What's supposed to be night time, except for this is being lit up by Jupiter over there, Jupiter star. So now let's increase the mass of Jupiter even higher. About this massive sun. Okay, the sun. I'll just increase it halfway. That should be good enough. 0.5% the size. The mass. Let's see what happens to Earth. Double day does get a little bit brighter. Let's see here. Where is Jupiter anyway? Okay, so it should be out this direction. Getting a bit brighter. Now let's increase the radius. Okay, radius has been increased. Now let's see what happens to Earth. And apparently nothing. Let's increase Jupiter's double day up even higher to 1% the size of the sun, or 1% the size of Jupiter, and just muck everything up. Okay, now 1% the size of the sun. Now Jupiter is still an official star. Mass 1% the size. 100% the size of the sun. Let's see what happens to Earth's double day. If it's still here. Earth's double day nighttime like thing. Should probably be more like evening by the looks of things. Martian evening. And then an earthly evening. Double Earth. Now let's see what happens to all the other planets. First of all, Mercury. Mercury gets this double day. Does. Very slightly. Let's see Venus. Is Venus going any hotter? Yes, it has. Venus is now officially glowing red at minus 77 degrees Celsius. Wonder how that works. Now Mars is minus 51. It's getting this double day as well. Let's see what happens if I get closer to Jupiter star. Okay. Seems as if the planets are drifting closer to Jupiter. Oh yeah, there's that Martian super day. And then there's a regular Martian day. Now let's see what happens if we put a moon around Jupiter. Even though Jupiter's got moons, moons don't load in. So let's see what happens if we put a Mercury-sized object around it. Never mind. Place it too close, now it's just torn apart. To a weird snake thing. Let's see what happens if I put wolf around it. The temperature of this little thing. 2,459 degrees Celsius. Dang it. Compared to 2,281 degrees Celsius. So this is just slightly hotter. Let's see what happens if the mass was to increase about 10 times the size of the sun. 10 times the mass of the sun. Okay, so Jupiter is now an official giant star. Okay, now let's see what's happening to Earth. Earth's double day is getting a little bit brighter. Never got to check up on the outer planets. See what's happening to Saturn. Saturn's not really that affected, it appears. Now what happens? Okay, let's just load up a solar system again. And see what happens if we throw a neutron star at it. Okay, let's see here. Star, 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 star. Where are the supergiants? Okay, so there we go, pulsars. Okay, let's see here. That one looks good enough. Now let's launch it directly at the sun. Okay, now let's start speeding up time for a few million years. As it draws closer. Okay, it's just entered the Kuiper belt. Seems as if it's got its own planets now. Okay, asteroids. Protoplanets. And that's going straight for the solar system. Let's speed up time even faster. Okay, slow down time a bit. Now let's see what's happening to Earth. Nothing really much apparently, except that it's got a double day. Very bright double day, and a regular double day, and then a night. Please click on Earth, there we go. Now let's see here. Chance of life is going down. If there's a neutron star. Now let's see what's happening to the magnetic field. The magnetosphere. For some reason it's not pointing at the neutron star. Unless the neutron star's somewhere. There goes the neutron star. Rest in peace, the sun. So that was just a big glitch. Now let's load up. Let's see here. Another scenario. What good scenarios are there? Of course you can create your own scenarios and save them. So just do that. Get anything you want. You can even increase the mass of the star so big that you get a supergiant. or you can create, or you can change the kilometers big, so you get this giant star, so big that it can be multiple light years across. Imagine that. They'll probably be able to support life on stuff in other galaxies once it gets a few light years big. Of course, the mass doesn't change. The surface gravity is so low that I don't think nuclear fusion would be supported at its core, according to surface gravity. So that's why we have to change this up. Mass up. So the surface gravity goes up. Should change the mass to 150. 1050 maybe. 1500 actually. Okay. Looks like 2000 should be safe enough for this car. And now let's say what happens, or where the Hubble zone is. Okay, the Hubble zone is about, let's see here, if I was placed down a planet like Earth, there'd be 6,451 AU out. Let's see what happens to Earth out here. This is even accurate. Turn off that ring grid. Okay, let's see what happens. Nope, Earth becomes a snowball. Again. But it's not entirely accurate. Well, it's actually accurate. But I just placed Earth in a little different zone. In a little different area. Now let's create a new simulation where, let's see here. Actually, I'll just create another solar system. And we'll see what happens if I launch. Let's see here. What would be best to be launched at the solar system? We could always launch. Now, that'd be perfect to launch Proxima Centauri. Okay, Proxima Centauri. Just for the good science spirit, so open up the Hubble zone and place down some sort of Hubble planet. Recently, scientists discovered a possible planet with life orbiting around Proxima Centauri. Might as well get into the good mood. Of course, it's frozen. Who cares? Okay, let's see it on its little journey out. There's the sun. Let's see what happens to the solar system. Okay. Right, look at that. The sun's wobbling a bit. Jupiter's wobbling the sun, like it always does. Okay, Proxima Centauri. Solar system collision happening in a few months or years. Or if I placed it too far out. I think I placed it way too far out. Anyway, let's do this. Load up the simulation. Let's see if all the stars implode in each other. Minutes a second, hours a second, days a second, months a second, years a second. Any difference? The strongest attractor seems to be. Where is the strongest attractor? What if I was changed the velocity up to 1 meter a second? Uh oh, something exploded. Looks like some of the planets are already beaten. Well, the stars have already beaten to location. Okay, anyway, let's do Earth and sphere of moons and see what we get out of this. Maybe if we're lucky we'll get a new moon created from all the rubble, or a new Earth. And all the liquid water's dried up. Let's increase the distance, the speed. Earth is now lava. Millions of years of impacts later. Still no chance of human life. There even was a chance of human life out here. Okay, all the rest of the moon's tearing up after 48 days. 48 days later, the impacts start to stop. The temperature is still a little bit high. So you could probably go and mark this Earth, bake a cake, come back. We'll see here the surface pressure is, let's see here. Okay, which one is the actual surface pressure of the Earth? I think it's changed, so there's going to be a little chance of human life. Down the water's gone. It's losing very little mass. Chance of life is going up. Skyrocketing. Water's starting to appear on the lava surface. Even though it's still 156 degrees Celsius. Slow this down. Yep, water defying the laws of physics, thermodynamics. I'm going to speed this up so it cools even faster and all the magma goes away. Something else crashed in. All things are crashing in but still cooling down. Something else was crashed into back from magma planet. Or the lag. Okay, let's see here. It's been 121 days, not even a year. The atmosphere has returned to its original state. This is going to be infinite collisions. I bet. Anyway, that's been enough Universe Sandbox today. So yeah, let's play this for a little while longer. Yeah, I'll quit off. Appears that life is back, so see you all later.